so I don't confuse the heck out of everyone. And forward, you got to include that direction. That's very important. Because if it goes the other way, then you have big changes. Plus, my acceleration of 2 times my time. 2 times 10 is 20. 20 plus 30 is 50. That means my final velocity is 50 meters per second forward. And those of you who are US based and wondering how fast is that, that is about 112 miles per hour. So the truck is really ready to wake. This sometimes happens on mountain roads. All right, so the truck wants to save itself. On mountain roads, something that's common is called a pull-off road. Probably not the exact name of it. And it's going to pull off the road. It's usually a gravel road that goes straight up a hill, so that if your brakes fail, you can go up the road without crashing before the next turn and save yourself. So now it's going to pull up this road. It's going to slow down as it goes up the road. So we have 2 questions now. We're going to find the final velocity after 2 seconds, and we're going to find the time it takes the truck to stop. So we're going to solve for time in the second one. So go ahead and put it on pause. For the first one, we have this one again, except for we have, since this one comes after the last one, I will do this quite often, where I have a continuation of a problem. It's based on the final answer of your previous problem. That's not always the case, but I do that quite a bit. A lot of physics is continuous. So we started off at 50 meters per second forward on the bottom of the last hill with the last problem. Now it's going to go up the hill, and my acceleration is -5. So what I'm going to do is I'm going to write plus a -5, like so. Because otherwise people ask me, do I add this or subtract this? And the answer is always you add it, but sometimes you add a negative. So effectively we're going to subtract it. And we have 2 seconds instead of 10. I think you might see the answer to the next problem, but I accept. So 50 plus -5 times 2, that's -10, is going to give me 40. So the answer to this problem is 40 meters per second. How long is it going to take? Well, in this case, what I'm going to do is I'm going to do something a little bit different. Sometimes in physics it's very helpful to wait till the very end to plug in the numbers. Now what does that mean? I'm going to solve this equation for time before I even plug in the numbers. Now this is going to look like a new equation, but sometimes it's the same equation, it's just rewritten, or solved for a particular problem. So acceleration times time equals v final minus v initial. And that means, I should write this a little bigger. I forget that the camcorder is in the back of the room. So acceleration times time equals v final minus v initial. To solve for time, I divide by a, and so my time is going to equal v final minus v initial divided by my acceleration. Now it's always important to use final minus initial. Okay. But what is my final velocity? I haven't given it here, have I? At least not directly. But I have given you enough information to be able to figure it out indirectly, through context. Remember, a lot of physics is through context. So you have to figure out what's happening in this problem. We're going to come to a stop. What is my velocity at a stop? Well, at a stop, I'm not moving. My position is not changing. Therefore, my velocity is 0. But always write in that 0. So my final velocity equals 0 meters per second. I encourage you to write it in units because 0, you don't have to write it in a direction because the direction doesn't matter. My initial was 50. And my acceleration is -5. All right, now, in problems like this, if you get a negative time, unless you intended to do that on purpose, which is probably not going to be the case, you probably made an error somewhere. And the 2 errors that people tend to make is that, one, they forget to do final minus initial. You might have done initial minus final. Or they didn't watch the direction. Now in this case we have forward and forward, those cancel cancel out, we're okay. So those are the two things to watch out for if you get a negative time at any point in time. So we have 0 minus 50, which is minus 50, divided by minus 5, which is 10 seconds. All right. So hopefully that's pretty straightforward. This would be level 1, level 2 problem solving. Probably call level straightforward level 2. All right. So now that we understand the relationship between velocity and acceleration, or changing our velocity and acceleration, let's put everything together now. So we're going to have two equations really to look at for motion problems. We have delta v equals at, even though I could write that out 3 or 4 different ways. And we're going to have this equation here. And we're going to get rid of the box at this point in time and put in the value that's in the box. So what is in the box? Well, x minus x naught, by the way, is distance, so we're going to ignore the x's. That's more for a trig-based class than for this class. So we have acceleration. If we have an acceleration, that's going to change our motion. If we have an initial velocity and it's constant, we move and our distance equals velocity times time. Now, if during that time I speed up, I'm going to be traveling faster than that initial velocity for the rest of the trip. And so I'm going to move an extra further distance. If I'm slowing down, I have negative acceleration, which means that my speed velocity is going to be less for the rest of the trip than it was initially. So if I do d equals vt with my initial velocity, that means I would have a smaller distance than expected, and that's because acceleration is negative. For math reasons I won't get into, as we don't do in this class, calculus, the distance moved with velocity, meaning if we start off at 0 velocity, we accelerated for some amount of time, how far we go in that time, is 1/2 the acceleration times the time, or time squared. Now, in this class, I try to avoid exponentials, just because it's a lower level math class. Now, in a trig-based class, for some of you maybe online maybe watching, it would be just t squared. So it's 1/2 acceleration times time times time. So the actual distance, this is the equation you use every time for distance, whether or not you have acceleration. Initial velocity times time plus 1/2 the acceleration times time times time. Now, if you have no acceleration, it goes to d equals vt. But always use that because you cannot use d equals vt when you have an acceleration. So if I have a race where even if I start out at rest and accelerate at some given acceleration, and I get to some distance and that's what's my final velocity, you cannot use that equation to solve for that velocity because that's not the final velocity, that's the initial velocity. You're going to have to use delta equals at for that one. If I give you the acceleration time and initial velocity, and say how far have you traveled, you can't d equals vt because you traveled a little bit extra distance because of the acceleration. You got to use the full equation. But your acceleration can always be negative if it's backwards. So acceleration from like friction and air resistance are usually negative, almost always negative. All right, let's do a quick example. We're going to have a truck that accelerates from rest. Actually, we're going to do two problems. The first one, it accelerates from rest, and the second one, we're going to have accelerate from 10 meters per second. And for both of these, you're going to have to calculate the time first. So this is a level 3 problem. You don't get very many of them, but this is going to be a level 3 problem because it requires two separate equations to solve. I'll give you a hint, you have to solve for the time first. Usually when you have to do motion problem with two separate equations, you're going to have to use both of these equations. Both of those equations. So we're going to do it two ways. We're going to do it with no initial velocity. We're going to do one with initial velocity 10 meters per second forward. All right, and for both, we're going to calculate the time first because you have to calculate the time first, and then you calculate how far the truck moves. All right, so go ahead and pause it. And do the solving. side by side. All right. So for the problem as written, time equals delta V over A, which is V final minus V initial divided by my acceleration. All right. For this problem, my final velocity was 50. My initial velocity was 0. And my acceleration is 2 meters per second squared. Forward. All right. So 50 divided by 0 is 50, divided by 2 is 25 seconds. Now, for this one, same setup. Because it's basically the same problem, I just have one extra number. I told you the initial velocity was 10 forward. Same acceleration. So we have 50 minus 10, which is 40, divided by 2, which is 20. Okay. Now, for the distance, we're going to have the same equation in both cases. D equals V naught T plus 1/2 AT T. Good more for my physics 100 class. Sorry everyone who's watching this for a different course. So, my initial velocity for this one was 0. For this one, it was 10. I don't have to put in the time for this one because 0 times time is 0. For this one, it was 20 seconds plus 1/2 plus 1/2 my acceleration. And notice I keep putting directions in, which seems very strange. Directions are your friend. And 25 seconds, 25 seconds. This one, I'm going to do a square just because I ran out of space. All right, now we do the math. You put this on the calculator, 1/2 times 2 is 1. 25 times 25 is 625. Yes, I know 25 squared. 10 times 20 is 200. And I could put meters forward if I really wanted to, but with distance you don't have to. Plus, 1/2 times 2 is 1. 20 squared is 400. And this gives me 600 meters forward. Now you're probably wondering, why was that a shorter distance when I started out with a higher velocity? Well, the reason being is that it's a shorter time. With this one, it takes me some time to accelerate up to 10 meters per second. 5 seconds. And in that 5 seconds, I'm going to travel 25 meters. That's why this is 25 meters longer than this, because in this case, I didn't have to accelerate up. I was already there. I could just continue on. So I basically started a further distance down the road. So I'm going to travel 600 meters. All right, so that is that. I believe that is my last. Oh, we have a deceleration problem. Okay. So for this one, I'm just going to do, well, I guess we have to do both of them because you have to find the time anyways. So we're now going to decelerate the truck from 50 meters per second down to 0. We're going to make it stop. So we're going to have to find the time again. The only thing that changes is where everything's located. My final velocity is going to be 0, because I'm going to stop. My initial was 50. And my acceleration, now I can either use 4 meters per second backwards, but if I have backwards on the bottom and forwards on the top, that doesn't work out so well. So I'm going to convert it to minus 4 meters per second squared forward. Because minus 4 forward and plus 4 backwards mean the same thing. Then this is going to be 12.5 seconds. And now I do this, same thing, to stop. So I'm going to use this equation again, but I'm going to write it out a little bit more, make it bigger. My initial velocity was 50. Now, rule of thumb, usually what you want to do is pick a direction at the beginning of the problem for each dimension and use that direction. So in this case, I've decided to do everything in the forward direction. And I don't have any other dimensions, so I'm just worried about forward and backwards. I could choose to do everything in the backwards dimension, in which case my initial velocity would be minus 50 forward, and my acceleration would be positive. I'm going to do forward direction, which means my initial velocity is positive, but my acceleration then is negative. You get to choose them, usually. Now the default is forward is positive and up is positive, usually. But sometimes there will be cases where you want to change that, and you get to do that. 12.5 seconds minus, I'm actually going to write the minus here because I have a negative acceleration. So in essence, I would have a negative in here, but I move the negative out to here. So hopefully I'm not confusing the heck out of everyone. 12.5 seconds squared. All right, so I've got to do a bit of math in my head now. That's 625 meters for this. This is, let's see here, this is 25 divided by 2. 25 divided by 2 squared is 625 divided by 4. That cancels out the 4, minus a half. So half of that is that. And so my answer is going to be 312.5 meters. Now if I was doing sig figs, I would probably change this to 310 meters. So I'm going to call this 310 meters to use proper significant digits. I don't know how much your physics class is going to focus on sig figs. I realize I only have one sig fig there. Pretend any time in this class, if I put something in one sig fig, pretend I actually use 2, so I use 4.0 instead of 4, just straight 4. There's one sig fig's kind of boring. Unfortunately, I don't have time to cover sig figs, which seems strange because I have all the time in the world, but and so this is the payoff pitch. And for this one, I'm going to erase the entire board while you read that problem. This is a projectile problem. This is a two-dimensional problem. Actually, no, this is a one-dimensional problem. I even have to read my own problems. I have to do these first two steps where I get it wrong. So if you're trying to do problems without those two steps and I can't do it that way, obviously you won't be able to do it that way either. All right, so let's have this problem. I'm throwing a ball up in the air. It's going to come up, stop, and come back down. We know that because we've thrown balls in the air many a time. Okay. So we get to decide how to set up the problem. And setting up the problem is most of the time key to solving the problem. So do you want the direct positive direction to be upwards or downwards? Pick a direction. Pick it now. Up or down. It doesn't matter which one, just pick one. No, pick the other one. I'm just kidding. I'm going to pick up. If you pick down, that's fine. Where do I want my starting position to be? Now this problem, this is more for trig-based, so I'm going to kind of skip over that. In the vertical, usually we're going to use the ground as 0, but you can choose the top of the building to be 0, particularly if you choose down to be your positive direction, because then the ground will be positive. Otherwise, if you chose the ground to be 0 and you pick down to be the positive direction, your distance is going to be negative, which is okay. That's fine. It just means that you have a different direction. Negative answers are good except for with time. except for wait time. So I'm going to pick the ground to be 0. I'm going to and I just realized the equation I gave to you is going to be a little bit tricky for this particular problem because the distance you're going to calculate is the distance from your initial position, and not the distance from the ground. So for this, you're just going to have to reason it out at the end. Sometimes you have to do that. And particularly this class, because we condensed the equations, because this is a lower level physics class. That's why it's a 100 level physics class, because we do less math. Not because it's intended to be straightforward, but because we use less math. Less sophisticated, less complicated math. So that means we sometimes have to reason through things. So and I just realized I probably have never given a sample problem in class. So we're going to change this problem slightly because this class is a little bit different than what I would usually use this for. We're going to assume that he starts from the ground, so it starts from 30 meters up. Now, if you start from 30 meters up, you'd have to use x equals x naught, and you would probably pick x naught to be 30, which is your initial position, instead of 0. Since we don't do x equals x naught for this class, I'm just going to start with 0, start at the ground. So now, since we only have gravity, this problem is going to be symmetric. The force is going to be the same force everywhere. And so this helps you calculate the time it's going to take the ball to hit the ground. Now here's how we calculate this out. Now if you have air resistance forces, it's going to be very different. But in this class, in this particular problem, we don't, so we don't have to worry about that. You're going to calculate the time it takes to get to what we call the maximum height. The maximum height. Now, what is the velocity of the ball at the maximum height? And I want you to think about that for a moment. What's the ball doing? It's going up and up and up and up and slowing down and slowing down and slowing down. It's going to get to some point, and it's going to start coming back down. What does it do very briefly at that point? Initially, before that, the velocity was upwards. After that, the velocity is going to be downwards. So at some point, your velocity is going to have to be 0. And at that point, that's where the ball stops, and that's called the maximum height. So let's calculate the time it'll take to get to maximum height. Now, how would I do that? I know the ball's going to stop, 0 velocity. I know I start off with 20 meters per second up. So how do I calculate the time to do that? Well, first I have to do the acceleration. Now, since this is gravity, gravity has a very specific acceleration. Now, it's 9.8, but in this class we're going to use 10 just to make the math more easy. So, time, again, equals delta V over A, which is V final minus V initial divided by A. My final velocity is 0. My initial was 20. And I draw a little up arrow for up. Divided by my acceleration. What is my acceleration? If you just write 10 there, notice your answer is going to be negative. The acceleration of gravity is 10 meters per second squared down. Now, since I chose up to be the direction, that means I have to make my acceleration negative 10 meters per second squared up. So 0 minus 20 is negative 20, divided by minus 10 is 2 seconds. If you use 9.8, you're going to get 2.04 seconds, so it's not a big change. Now, what is the answer for A? Because the answer is not 2 seconds. Because 2 seconds is how long it takes to go up. Now it has to come back down. Oops. Well, we have a symmetric problem. As it falls, it's going to have the same motion as it went up. 1 second before it stopped, it was traveling 10 meters per second up. And then 0, 20, 10, 0. As it goes down, it's going to do the same thing. 0, 10, 20. In fact, when it hits the ground, it's going to have the same velocity as when it left the ground. Now, that doesn't mean that it always has the same final velocity as the initial. If you're standing on top of a hill, you throw a rock, it's going to hit the ground usually with a higher velocity than it left your hand because it falls a long distance. So it has more time to accelerate. In this case, it's going to take 2 seconds to go up and 2 seconds to go down. So my total hang time is 4 seconds. So that's my answer to 2. If I had a horizontal velocity as well as a vertical one, and I wanted to calculate how far that ball was going to land from the initial starting spot, I would just take 4 seconds times my velocity. Because in the horizontal, there's no forces if I get air resistance, and so it's just going to keep moving. So if I moved 10 meters per second forward and 20 meters per second up initially, so I throw it at an angle, it's going to take 4 seconds to hit the ground again, and it's going to move 40 meters, 10 times 40. Hopefully that made a little bit of sense. All right, so what height above the ground will the ball be after 3 seconds? I can take any amount of time to calculate the height of the ball at that point. In fact, I can calculate the maximum height by using the 2 seconds, and I'm going to have to use d equals v naught t plus 1/2 at squared. And in this case, I'm going to use 3 seconds. And again, my acceleration is negative because I picked up to be the positive direction. And so now I do the math. 20 times 3 is 60. This is 5 times 9, which is 45. 60 minus 45 is 15 meters. So that will be my head above the ground after 3 seconds. Right. So that's pretty much all there is to motion problems. The only way to make it more complicated is to add a second dimension to make it a projectile problem. Which is more of a problem you see in a trig-based class than in this particular class. So we don't see a lot of projectile problems in this particular class. And so this one is a fairly quick one. Ball falls for 5 seconds. How far does it fall? So we do d equals 1/2, or so v naught t, which is 0, because we just dropped it. I can do that to indicate that that's 0. Plus 1/2, my acceleration is 10 meters per second squared down. Here I'm going to pick down to be the positive direction. Because my initial velocity was 0, I get no advantage to picking upwards as my positive direction. Usual rule of thumb, if you throw a ball downwards or you drop it, you're going to probably want to pick down to be your positive direction. If you throw a ball upwards, it's give and take. Probably want to pick upwards to be the positive direction, but you don't have to. Then 5 seconds times 5 seconds. So this is 5 times 5 times 5, which is 125 meters. All right. So far, so good. Now, what is the velocity of the ball when it hits the ground? I want you to do this problem. I definitely want you to try this problem because there's a good chance you're going to make a common error, which I want you to get out of the way now instead of waiting till the exam to get it out of the way. And to see why that was an error. All right, I want everyone to do the problem. Put it on pause, do the problem. I don't think you paused it. All right, so now some of you probably wrote d equals vt and solved for v and got 25 meters per second. That is not the correct way to do it because there's an acceleration. And furthermore, this only goes for the initial velocity, and I'm asking for the final velocity. So when you have an acceleration, you're going to have to use this equation. So go ahead and use that equation now. If you used this one before, go ahead and pause it again. Oh, wait. Actually, I don't have to wait because I'm going to pause. All right. Delta V equals AT. V final minus V initial, which again was 0, equals acceleration. And I know my handwriting is terrible. I have a doctor's handwriting, but it's okay because I'm technically a doctor of astrophysics. And that gives me 50 meters per second down as my final answer. Now notice it was exactly twice the other because what the other one was the average velocity. And in this case, the way the problem is set up, because we started at rest, the average velocity is 1/2 the final velocity. Because on average, 1/2 the time you're doing less than that, and on average you're doing more than that. And so your final minus initial divided by 2 is your, in this case, your average velocity because you have a constant acceleration. So that's why they're different by a factor of 2. All right, and I'm pretty sure that is the end of this lecture. You survived lecture video lecture number 1, and I am going to skip this one. Because it's almost identical to the one where we just started straight up. The only difference is, well, this is actually a trick-based one, so I can't do it for this class. But if you're taking it, since we're algebra-based, so if you're taking a trick-based class, you can go ahead and do this problem. It's gave you about 2 seconds of hang time, not a very good kick. You're looking at about a 34 meters distance. So, if you're not in if you're in my physics 100 class, you didn't follow that, don't worry, because that is beyond the scope of our class. So to wrap up, we learned pretty much everything we need to know about motion in our class. If you are, again, in the trig-based class, you need to go a little bit further into projectiles. Just type in trig-based projectile problems, physics, and you'll find plenty. If you want more practice problems, you're in Physics 100, just type into Google motion problems, algebra-based. You'll probably find quite a few. We learned how to use distances, velocities, and accelerations, and how to find time. And the other way to make this more tricky is at the second dimension, which we do with projectiles. I don't think we actually do projectiles in this class much. So that's pretty much it for motion for us. And if you have any questions, ask them at the beginning of class, the next class period. I'll take about 10-15 minutes for questions based on this lecture, and then we'll do basically the homework. Or actually, we'll do the recitation. Then the next class period, we do the homework. That's going to be the order of events for our particular class. Hopefully you found this lecture to be useful and helpful. Feel free to give me comments, both on YouTube and outside of YouTube. But I try to do it in a way that's anonymous, so that if you're actually in my class, I can't figure out who you are, even if they're nice comments. I will see you all hopefully in the next lecture. This will be a series of about 25 lectures for those who are not in my Physics 100 class. For those in the Physics 100 class, it's about 25 lectures. And of course, at the end of all of these, since I have to turn off the camera with an extreme close-up. Okay. Goodbye and good night. Now for your local news.